Welcome back, Calculus. We are going to be looking at approximating and interpreting derivatives from a table today. I've got the checklist, so I'm going to force a pause on your screen. Make sure you've got everything ready to go, especially being in full screen mode. Alright, so before we get started in looking at some examples, we've got a little bit of background to cover. So first of all, what does it mean to be differentiable? So to be differentiable, it means that the slope of the tangent line exists at whatever point of interest we're looking at, okay? And to be differentiable, you have basically two conditions. Do you remember what those two conditions are? You first have to be continuous, right? And then in addition to being continuous, the function also needs to be what mathematicians call smooth. In other words, no corners, no cusps, no vertical tangent lines, okay? So that when I zoom in enough, my function starts to look like what? Starts to look like a linear function, okay? All right, so the derivative of a function at a point is the function's what? It's the function's slope there, okay? And what does the slope give us? It gives us our rate of change. In other words, it measures how fast our function is moving with respect to our dependent variable. Typically that's time. Okay. All right, so I'll force pause on your screen. Go ahead and copy what you want to copy from my screen, and then we're going to continue. All right, so can you go ahead and write this first phrase in your notes for me, average rate of change? Okay, so let's define average rate of change. That is the type of thing you should have calculated in Algebra 1 and Algebra 2. This is technically the slope of the secant line. And remember, secant in Latin means to cut, okay? So I'm cutting the function at 2 points. We typically call those points x equals a and x equals b, okay? So to find the slope of the secant line, it is my rise over run, so change in y over change in x. Sometimes we denote that instead as f of b minus f of a all over b minus a, right? So just my rise over run, change in y over change in x, so slope of 2 points, okay? That, again, is if you see the word average rate of change, so between 2 points, one time interval, okay? Now in calculus, we can now calculate the instantaneous rate of change, also just known as the rate of change, okay? And this is the slope of, what do you think? Of the tangent line, yeah. So the instantaneous rate of change is also known as the slope of the tangent line. Remember, tangent in Latin means to touch, so you're just going to touch the function at one point. It could intersect at others, but we're looking at one particular point where if I zoom in enough, again, that point starts to look like a linear function, and that linear function, or that line, is what we're trying to draw, okay? So this instantaneous rate of change occurs at 1 point, okay? And we denote this in a couple different ways. The most common is just f prime of x, or whatever our x value is, okay? You may also see dy dx. Looks like dy over dx, but it's pronounced dy dx. Where do you think that comes from? Absolutely, that's our version of this change in y over change in x, right? So a couple different ways. Those are the two most common ways you'll see the derivative, and so let's put that on here as well. So the derivative is what gives me my instantaneous rate of change, okay? My the slope at 1 point. All right, so we have got some calculator commands we need to cover today. I'm going to go through both the 84 and the Desmos. If you have your own 84, you can go ahead and fast forward through the Desmos part of this. If you are borrowing an 84 from me, or you just, pick one up at class time, I want you to really concentrate on the here's Johnny, on the Desmos commands as well. Say hi, Donnie. Yeah. Okay. No, now's not the time. Okay. So I'm going to force pause on your screen. Go ahead and copy what I have. You may need to push continue and then pause on your own as well. All right, so if you have your own 84, go ahead and grab that, and let's practice these commands. If you don't, I still want you to watch these because on the AP exam, you're going to have to learn how to do this on the 84. All right, so let's type in our function. We're going to go to y equals, let me clear everything, and we are going to type x cubed minus 2x. If I go too fast, just pause me. Then we're going to go to second, quit to go to our home screen. Then we're going to go alpha, trace, enter, parentheses 1, and this is going to give me f of 1, okay, which we should be getting -1. All right, our next exercise said find the average rate of change, so that's just the slope between 2 points, remember? Average rate of change of f on the interval 2 to 4. So first let's come grab our fraction, okay, because I want my change in y, so remember y is alpha trace enter. I'm going to grab y1 and tell it to find y1 of 4, f of 4, minus alpha trace enter, y1 of 2, and then all over 4 minus 2, or just 2. Okay, so there's my average rate of change, 26, okay? Now for the instantaneous rate of change, that's going to be your derivative. So to get your derivative, go math, it's right under the green button, 8. And this is going to pull up the Leibniz notation for the derivative. So then you're going to have d dx in the denominator. Then the function is going to go in the big parentheses, so remember alpha trace enter. And then I want to find this at x equals 1. Enter. And there is my derivative, or f prime, at x equals 1. All right, now let me show you Desmos commands. All right, so I'm really just going to focus on this part of my screen. I don't care so much about my graphing area right now. So step 1, type in your function. Be sure you call it something. I usually use f of x. So f of x equals x cubed minus 2x, okay? Now if I want to get f of 1 in line 2, I'm literally going to type f parentheses 1. And we see right there, we're getting the same thing as we got on the 84. If I want average rate of change, let's go ahead and open up parentheses. So we did f of 4 minus f of 2 all over 4 minus 2, which is 2. And there's our 26. And then if I want the derivative, which is just going to be f prime, use that little apostrophe of 1, and there's the 1 that we got there. Notice that your 84 kind of had a hard time at the end there with all the decimals. You're always required to give at least 3 decimals on the AP exam. You can always do more, but at least 3. So you notice if you go to 3 decimals, you would have had the same number whether you're using Desmos or the 84. All right, so now let's look at our example. I have one example for you with, I think, 7 parts. So I'm going to force a pause on your screen. All I want you to copy for me right now is the table. So go ahead and copy the table for me. Okay, so let's take a look at this problem. It says water is flowing into a tank over a 24-hour period. The amount of water W in the tank at various times is measured, and the results are given in the table above, where W is measured in gallons and T is measured in hours. There are 150 gallons of water in the tank at T equals 0. So whenever you have a word problem, always think, what is my function giving me? So in this case, what's our function modeling? So the function is modeling the amount of water in the tank. Yeah. it's given in gallons, but what it's giving us is the amount of water. Okay, so for part A, just write an A in your notes. We want to find W of 8. So I'm going to circle that. So W of 8 is what? 221. You don't need to recopy all of statement A. Just put W of 8 is 221. Then it says using appropriate units, let's explain. So here's how I'd like for you to explain. At T equals 8, what are the units for 8? 8 hours. Now restate what the function gave you, which was the amount, that's what I underlined, of water in the tank is 221, and what's my units there? Gallons. Okay, part B says use the data from the table to find W inverse. Remember, inverse is switching x and y's of 257 using appropriate units. Explain the meaning. Again, you don't need to rewrite that whole sentence in your notes. Just put B and then put W inverse. So now, going the other way, W inverse of 257 is going to be 12. Okay, so when there are 257 what? Yep, gallons of water in the tank. T equals 12 what? Hours. Okay, and right now these are more algebra examples, but what I'm wanting you to really take note of here is that notice every time I pull in a number from the table, I'm also attaching its appropriate units. Okay, so that's what I want you to really get into the habit of. All right, in this case, I am going to force a pause on your screen. You don't need to copy everything. I just would like for you to copy part C in your notes, please. All right, so let's look at part C. It says for time between 0 and 24, must there be a time t when the tank contains 265 gallons of water? Justify. Okay, so what does this remind you of anything? Hopefully this reminds you of IVT. So let's see, 265. Well, if I look at 0 and 24, my the amount of water in the tank is 150 and 357 respectively. So is 265 between those two given y values? Yeah. And by the way, if it isn't, you're always allowed to look within the interval. If your two time values are not right next to each other in the table, you can always go in between. Okay, but in this case it works. So we're going to say yes. By what theorem? IVT. Then I need to state why I can use IVT. Since, now this is really important, and I saw this a bit on the test. A lot of you put like the function or the graph or f of x. We cannot do that, okay? You have to state specifically what function we're talking about. In this case, since W of t is continuous. And, all right, the y value we're trying to prove exists is 265, which is between 150 and 357. And this is W of 24, and this is W of 0. Okay? Again, really want to emphasize that I need W of t is continuous here. I also saw a lot of t is continuous. Okay, we know time is continuous, but we need to indicate that our dependent variable is continuous. Okay. All right, part D, you do not need to write that statement. Let's work it together. It says use the data from the table to find an approximation for W prime, which is the what? The derivative. Show the computations that lead to your answer, and then using appropriate units, explain the meaning of your answer. Okay, so for part D, we're going to put W prime of 15. Okay, and we're going to approximate this. So the derivative is a slope at how many points? At 1, right? I can approximate it using the 2 points around 15. So what are the closest two time values that is given on the table to 15? Yeah, 12 and 16, right? So I can approximate this by saying this is close to the slope between those 2 points. So change in y, we usually write it like this, w of 16 minus w of 12 all over 16 minus 12. Okay, so let's plug our numbers in. Our change in y is 294 minus 257. And our change in x is 16 minus 12, which is 4. Okay, a couple notes. You can actually leave your answer like that on an FRQ. You never have to simplify all the way. However, your answer does have to contain only numbers, okay? So I would not be able to leave it like my first statement because I see letters in there, but I actually could leave it in this form that I have here. However, one thing you cannot do is just jump straight to the answer. Even if you could do that computation in your head, I have to see a difference, meaning subtraction, and a quotient, meaning division. Okay. So this does simplify to 37 over 4. And what would be the units here? Well, let's be really careful because these numbers came from here, which was gallons, correct? And then these numbers came from here, which was hours. So what do you think the units would be? It's going to be gallons over hours. Okay, so now, and it's really important, let's explain the meaning, okay? Do not get creative here, just go ahead and follow my template. So you're going to put, you're always going to state what time value you're looking at first. So at t equals 15, what? Hours. Okay, then you're going to restate the function, which was the number of gallons in the tank, or the amount of water in the tank, either way, is, and then you're going to say either increasing or decreasing. Which scenario do you think I would have here? You're going to have increasing because your derivative, your slope was positive, right? If it were negative, go ahead and put decreasing. And then you're going to say at a rate of, and then put the absolute value of your answer. So 37 over 4 gallons per hour. Why do you think I would say take the absolute value of your answer? You need the absolute value because if you got a negative number, you did not want to say that it's decreasing at a negative value because now we're back to increasing, okay? So make a note for yourself, put absolute value of answer here. Okay. All right. Okay, so part E says use the data from the table to find the average rate of change of W over the time period 4 to 20 hours. Show the computations that lead to your answer. I'm going to have you try this one on your own. Go back and look at the definition for average rate of change if you need to. Then click continue and you're ready to see the answer. Okay, if you chose to keep it as a decimal, we should have gotten 8.9375. We need at least 3 decimals, and you can either round or truncate. So we could have what I have. We could have 8.937 if you truncate, 8.938 if you round. So truncate means just chop it off, cut it. But you cannot have 8.94, okay? You cannot have that. It would be counted wrong on the AP exam. So always give me at least 3 decimals. All right. I'm going to force a pause on your screen. I would like for you to copy simply A of t. So part F says a model for the amount of water in the tank is given by A of t, where A is measured in gallons and t is measured in hours. Find A prime of 15. I'm going to use Desmos. Feel free to use an 84. If you use an 84, remember to get the derivative, you go to math 8 after typing in your function. All right, so I've typed in A of t. Notice I've even called it A of t. You're welcome to call it f of x if you prefer. But if I want the derivative, I would simply type in A apostrophe 15. So my answer there is 9. Okay, and then part G asked me to find the average rate of change, so slope between 2 points, between 40 and 20. So try that on Desmos or the 84 and let's see what you get. All right, so I got this decimal 8.995 repeating, it looks like, so we could put 8.995 or 8.996 on the AP exam. All right, you all, I will see you next time.